So in this tutorial, what we're going to do is we're going to look at creating 3 different types of mirrors and how you can do it. As you can see, I'm in just a test scene for the VR prototype. So what we're going to start with is we're going to need some mirrors or something that can work as a mirror. So I'm just going to set up 4 planes because I'm going to show one in a different way. So they're going to act as our mirrors. Now what we need is a material. So we'll just name that mirror. And in here, if you hold down 3 on the keyboard, you'll get a vector 3 constant, which is just a color value. So we're actually going to set this to a light grey. Hook it up to base color, and in the metallic and roughness, we just need to set up a single constant, but in the metallic we're going to set that to 1. So with that done, you'll actually see we have a mirrored sphere. What we need to do now is actually scroll down on the details panel and enable high quality reflections and planar reflections, as they're going to be used for this. Now we just hit apply and save. Cool, with that done we can save and close that down, and now we can apply this to where our mirrors are going to be. See, they're all black. I'm going to rotate this around actually. That'll give us a little bit more light. And so the first 2 I'm going to show you is pretty much the ugly way of doing it. So you go to visual effects and you can drag in a box reflection capture. And we're going to set that to 0 for the box transition distance. And if we make it a bit smaller so it only works in the 1. Scale it up a bit, just so it fits. Cool. So that's that one done. Put it in. Oh, that's not looking right. Chances are we just need to build reflection capture. Nope. Why are you looking like that? Transition. Not really sure what's going on with that one, but it's not the focus anyway. So you can see the box transition isn't really the best one to go for anyway. It's a lot of warping and distortion. And the other thing is, when you run it in editor, it doesn't actually update when the player runs past it. It's only built once, the reflection. So we'll do the same with a sphere reflection. Bring this up a bit. So, roughly in the middle, set that to 2 so we've got a bit of brightness. We'll keep it there. So that's a sphere reflection at 300. It's a little bit better. Do build reflections again. That's it, done. Now if I play this so we can see it in the editor, when I actually go up to it, we won't get any information out of it. Nothing. We can't see ourselves in the reflection. And also they're pretty bad quality, which I'll show you how to increase in a minute once we've got the other 2 done. So now what I'm going to show you is the planar reflection. So planar reflection it's really expensive to begin with. So it actually renders the scene twice, and you also need to enable global flip plane when you have it in your level, otherwise it won't render properly. So let's scale it down. And place it to the correct place. So ideally you want this overlapping with the object that you want to do reflections with, but you'll find that doing it on a sphere or any shape that's not entirely flat is quite difficult to do. So I'm going to change the distort distance down, and bring forward the roughness. Distance from plane, we'll put that up a little bit, just get rid of them dark edges. Distance from plane, put that down. Good, and we'll upgrade. We'll set up the screen percentage up to 100. That way we just get a sharper image. So if I go into it now, you'll be able to see that we can actually see ourselves in it, and it's really accurate. It's really good as well. But the downside to this is everything you see in the world is rendered twice, and if you have another one, for example, it will be rendered again, which adds to your compile times as well as your shader count. So this is a use sparsely case, so you don't want to use this for everything. It's really good for architectural visualization, and there's some tweaks that you can do which we'll go into in another tutorial on how to optimize planar reflections. But for now, what we'll do is we'll leave that, and I can actually show it. So if I use the GPU profiler, I open that up, you actually see how much performance we're actually getting. We're actually losing from the planar reflection itself. So it's now 12.9 milliseconds has been added onto our render time just because of adding that into the scene. So it looks really nice, but be really careful when using it. And the next one I'm going to show is actually how we can use a camera to look at the player and then project what it sees onto the mirror. So it's a little bit nicer than using the planar reflection for performance, but there's still some tweaks that need to be done with it. So what you first need to do is get a cube, a scene capture cube, which will look like this little camera, and I'm going to set it up in the middle of our mirror. So what we need to do now is actually create a cube render target. So materials, we're going to look cube render target, just name that appropriately, and in here you've got a bunch of settings. I'm going to increase the size just so we've got a better image to 1024, just a little bit sharper. But with the scene capture cube selected, we can actually drag this onto there, and now we can see it's updated this image. So we can actually use this to create a material. So, camera mirror. So opening this up, all we need to do is drag this in and hook it up to emissive. So you see that we need actually UV inputs. We're actually going to use the reflection vector in world space, so it'll know where the user is looking or the player is looking at the mirror, and it'll render the 360 around that. So with that done, with shaders compiled, you can see it looks a bit funky. I'm going to hit apply and save. You want to hook this up to the emissive color, that way it'll actually be bright. If you hook it into the base color, it comes out quite dark. So to get it accurate, you're going to need to use the emissive color. So we can close that, and we can now drag this onto the scene. So you can see now we've actually got what looks like a pretty good mirror, but there is some issues. So you can see, for example, the scaling is a bit off, which this is pretty good when you're up close to it and it's running in a game, because you'd have the resolution a little bit lower, or you would have less information seen in it. But what I'm going to do is, if I press play and we walk up to it, you'll see that we're actually quite high up. That's because the camera is being rendered all the way up there, pretty much in the center of the plane. So what we're going to do is actually set up a blueprint that sets the camera height based on the player's position. So I'm going to select the camera, I'm going to go to blueprint, convert selected component to blueprint class, just so we can actually see where it is. I'll put it in materials just because I've got this as the mirror stuff, not rename it. BP underscore BP underscore mirror. Let's create that. So now with this open, all we've got to do is pretty much get the camera location for the player and the wall position for this. So we can drag off these because we'll be able to bring them in a second. We need to use new scene component, and we need to get the world location. So we actually know whereabouts it is in the world, and I'm going to break that struct. And then we need to get the player camera position. So I'm going to use the get player camera manager. And then get the camera location. And split the values from that too, because we're only going to need the z-axis. So now what we need to do is fire it every time the player's head moves. So we'll do set location. I need to drag off this one. Set world location. We're not going to touch the rotation. Okay, never mind. What we're going to do is we're going to use the set world location because we don't actually need to touch the rotation. So that done, we're going to hook it up to event tick, and we'll split the struct. I'm going to use that. Yep. So they're not going to change, so it can keep its current value. But we're going to use the z-axis to control where the player's head goes. So hit play. So first compile that. So that's pretty much all it is. And now if we jump back into the scene and go back over to the mirrors, you can see we're actually a little bit more on the floor level, and we can see ourselves now. So that's not so bad. There is still some performance issues with using this, especially if you capture every frame. I believe it's every frame anyway. So you can see if I open up the GPU profiler as well, where this technique is actually using more than just the planar reflection. The reason for this is it's using 6 different cameras to create the 360 sphere image that we're actually seeing in the mirror. But you can reduce this down. Undo that. Check that out. We can actually go to the blueprint that we set up and scene capture and remove capture on every frame. And save, compile, play again. See, we're back in it now. So not much has changed, it's still working. But if I back out and then do the GPU profiler and bring it over, you can see now that we're actually back down to the planar reflection taking up the most performance hit. So it's just a balancing act. I highly recommend using the planar for architecture stuff, where you need something really crisp and really nice. But if you don't have to have it that quality or that high detail, then I'd recommend just keeping with the camera or try and avoid using reflections in general. It's much better performance wise and it'll give you more optimization later on. But yeah, so that's 4 different ways to create a mirror in Unreal, from essentially worst to best. And you might be wondering why, if these look much clearer than yours. The reason for that is in project settings, I actually increased the render size, so reflection capture resolution. No, I didn't on this one. Weird. But we can actually upgrade that, and then look at them, and you can see just by changing the value of this, it will change the resolution of all your reflection captures within the world. So you have to be careful when doing this, because it's not just these, it is every reflective surface in the world gets improved by this. So yeah, hope that helped. If you've got any questions, and if you've got anything else you want to see, curious about anything that we can do in VR, drop us a comment. We'll see what we can get done. Don't forget to like and subscribe, and you'll get notifications when new videos are uploaded. See how it goes. Cool.